Hello everyone, welcome to our channel 2 Bits. Those who are new to this channel, let me tell you that this is our 5th video on the Linkedlist series, and in this video we will be discussing the question intersection of two linked lists. In this question we are given heads of two singly linked lists, head A and head B, and we need to return the node at which the two linked lists intersect. And if there is no intersection, then we need to return null. For example, here we are given head A and head B, and this node is our intersection point, so we need to return this particular node. Now let's see how we are going to solve it. Our first approach will be, we will be using hashing. We create a hash table, we store all the nodes of the first linked list, then we traverse the second list and we see if there is any node in the hash table that has already been visited. If there is such a node, then that means that is the intersection node. And if there is no node, then that means intersection does not exist. For example, here we have head A and we traverse this list. So we traverse this list, we first go to 1 and we put it in our hash table, then we go to 9, we put 9 in our hash table, then we again go to another node 1, we put that in, then we visit 2 and then we visit 4. Now please remember that we are storing the complete node and not just the value of the node, because value can be repeated. Traverse the second list, we start from 3, we check if 3 is already visited or not, so the node 3 is not visited, then we move to 2 and we see that 2 has already been visited and it is present in our hash table, so we will return 2 as our answer. Now let's see the time complexity of this particular solution. So the time complexity will be, suppose this particular linked list is of length m and this linked list is of length n, then first we are traversing the list m and storing it in our hash table, and then we are traversing the list n and checking whether any node is present in the hash table or not. So the time complexity would be order of m plus n. Now the space complexity would be order of m, as we are storing the complete list 1 into our hash table. Now let's move on to our optimized solution. Now in this solution, what we will do is, first we will traverse the both lists simultaneously. For example, this is temp 1 and this is temp 2. So we will move forward temp 1 and temp 2 simultaneously till we reach the end of the list. So what we are going to do is, we traverse both the lists and we calculate the length of both the lists. For example, the list 1 has the length of 5 and the list 2 has the length 6. We see that list 2 is longer than list 1, so we calculate the difference of the longer list minus the shorter list and we get 1. So what we will do is, we move T2 one step ahead. So we reach here. Now move both T1 and T2 simultaneously, and at the position at which they match will be our intersection point. For example, here we move T2 one step ahead. Now we will move T1 and T2 simultaneously. So in the next step, T1 will reach here and T2 will reach here. And again in the next step, T1 will reach here and T2 will reach here. So we can see that T1 and T2 are both pointing at the same node. Then that means this node will be our intersection point. So we will simply return this node. So what we did in this solution was, first we calculated the length of both the lists, then took a difference of both the lists and moved the longer list by that many steps, and then we again move simultaneously, and when the pointers become equal, then that means we need to return that particular node, otherwise we will simply return null. Now let's see the time complexity of this particular solution. So first what we did was, suppose this is the list with length m and this is the list with length n. So first what we did was, we calculated the length simultaneously, so it will take the time of the longer linked list. So n is longer here, so it will take n time, order of n time. Then what we did was, we calculated the difference in the length and moved the longer list by that many steps. So that means we moved the pointer by n minus m steps, and then we traverse simultaneously to check out whether we have any intersection point or not. So we will traverse order of m. So this will be a time complexity and we are not using any extra space, so our space complexity will be constant. Now this solution is a little bit longer to code, so we will see another solution which will have a similar time complexity but it is easier to code. Now let's see how the solution works and then we will discuss why the solution works. So let's say we have a pointer A and we have a pointer B at both the heads of the two linked list. So we will move both A and B simultaneously, and when either of these reach the end, when either of these reach the null, suppose A reach the null, so we will make it point to the second list, and if B reach the null, then we'll make it point to the first list. Now in the first step, A will move here and B will move here, and in the second step, A will move here and B will move here. Then again A moves here and B moves here, then A moves here and B moves here. Now in the next step, A will reach null, so we will make it point to head of the second list, and B will reach here in that step. Now in the next step, B reaches null, so we will make it point to head of the first list, and in the same step, A will reach here. Now you see that B and A have aligned, and when we keep them moving simultaneously, they will reach at this particular node at the same time and they will match. So that means that this is the node that we need to return, as it is the intersection point of the two lists. Now let's see why this solution worked. When we started, A was here and B was here, so A had a head start of one step. So obviously A was going to reach here one step before B reaches here. And when we moved A to the head of the second list, A covered this one extra step and B and A aligned at that particular point. So the head start which it got at this particular moment was covered when A reached the head of the second list. Similarly, if there was one extra node at this particular list, so A would have a head start of two nodes in the beginning. But then A would have also covered that two steps here before A and B aligned together. So the distance that was skipped at the beginning was covered when the A pointer was pointed at the head of the second list. And if there is no intersection between the two lists, then both of them will meet at null. So when both of them point to null, then they will be same. So we will stop the loop. Now let's see the Python solution for this particular question. So what we did was, first we took a pointer A and pointed it to the first list. Then we took a pointer B and pointed it to the head of the second list. Then we checked if any of the list is already null or not. For example, if A is already null or B is already null, then that means there is no intersection. So we will simply return null. Next, what we do is iterate till A is not equals to B, till they do not point to the same node, as we need to point to the intersection node. So till they do not reach the same node, we will iterate, and our conditions were that if any of them reach null, we will point it to the other list. So if A reached null, we will point it to the B list, and if B reached null, we will point it to the A list. Otherwise, we will simply move them simultaneously. So in else condition, we have A is equals to A dot next, and in else condition here we have B is equals to B dot next. And when they reach, we know that they will reach the intersection point, so we will simply return A here. So this was the Python solution for intersection of two linked lists. The link for the C++ solution is given in our description, and the link for our Telegram channel is also given in our description. Thank you for watching. If you liked the video, then please like, share and subscribe to our channel, as it motivates us to create more such content for you.